Good morning. On behalf of Treon, I would like to welcome everyone who has joined this webinar. Today is 24th of June 2020. It's really amazing sunny weather outside here in Finland. My name is Ibek, and I'm Business Development Manager at Treon, and will be moderator of today's webinar. The topic of which is related to wireless condition monitoring. In this webinar, Treon and its strategic partners in the face of Sulzer and Danfoss will share with you insightful information related to Treon wireless condition monitoring solution and elaborate on why it enables predictive maintenance on a completely new scale. But first, allow me to introduce today's presenters. On behalf of Treon, we have Janne, who's product management leader as well as co-founder of Treon. Janne will reveal more information in regards to Treon industrial node as well as Treon gateway and elaborate on some of the technical aspects of the product. Our guest speakers today represent globally leading organizations in the industrial domain. On behalf of Sulzer, we have Matthew, who is a data analytics and smart technologies manager at the company. He will introduce Sulzer's wireless condition monitoring solution and tell more on how they utilize Treon's device as a part of their solution. Then we have Simo, who is head of IoT at Danfoss Drives. Similarly, he will introduce Danfoss Drives and their digitalization activities and reveal how our product contributes to the success of their journey. The housekeeping rules are pretty simple and straightforward. This webinar is being recorded and will be sent out to you automatically on your email after it concludes. The questions are to be asked via the question panel in your console. The Q&A session will be held by the end of this webinar, and for some of you, the presentation will be shared on demand as well after webinar concludes. The agenda for today will start with introduction to Treon, then followed up by an overview on condition monitoring and predictive maintenance concepts, as well as its challenges, and proceeded with Treon industrial node elaboration and customer success story by Sulzer and Danfoss. Then we will conclude the webinar by Q&A session. To start with, Treon is a wireless hardware making company. We are located in a beautiful city of Tampere. Interestingly, the place in which we are located has historical value to our organization, since Tampere is the first city in Nordics where the first electric light was lit at the Finlayson factory. And generally, there were many truly disruptive innovations, such as digital telephony and generations of mobile phone developments. And our values here at Treon are built around this rich historical heritage, and delivering truly world-changing technologies is essentially in our DNA. Our progression and growth has been rapid for the last years as we are introducing more and more industry-changing devices by tackling a variety of verticals. As you might see on the presentation slides, those are smart buildings, as well as industrial sector and transport and logistics. On a side note, soon we will introduce our unique IoT platform related to massive IoT, and also have a webinar on this topic, about which I will mention by the end of this webinar. So you might want to stay tuned on that. To elaborate on the topic of predictive maintenance and condition monitoring, I would like to refer to this interesting statistics provided by International Society of Automation, which stated that roughly $650 billion is lost globally each year due to machine downtime. And looking at this number, it doesn't come as a surprise that predictive maintenance concepts, as well as condition monitoring, is considered as one of the fundamental concepts of Industry 4.0. Generally, both concepts of condition monitoring and predictive maintenance are as simple as they might sound. Predictive maintenance is all about anticipating what failures may occur in the industrial machinery and what maintenance need to be performed in order to prevent them from occurring. And condition monitoring refers to the monitoring of the condition or the health of equipment. And in the industrial plant setting, those equipment can be pumps, turbines, blowers, motors, and any other rotating equipment that is going to fail at some point. So condition monitoring allows to monitor the equipment state in order to identify the damage or potential upcoming failures. As you might see on the slide, one of the most common methodologies for condition monitoring is a vibration analysis that allows maintenance engineers to have the longest lead time before any fatal error might occur. So in other words, PDM and condition monitoring, PDM is one of the ways in which condition monitoring can be leveraged. And these two are complementary and refer to the process of gathering and acting upon sensor data. Obviously, the influence of PDM on production costs are tremendous and undebatable, of course, if executed appropriately, and can literally save millions in MRO costs and general production costs for manufacturers. The data is essentially the fuel behind any predictive maintenance activities. However, this also poses specific challenges to PDM, and they are mostly related to data quality, quantity, and coverage, which leads us to different methods of acquiring data. Now, coming to the generation of sensor data, there are essentially two ways of doing so. The first one is more traditional approach through wired condition monitoring systems, and the second one is IIoT-enabled newly emerging wireless condition monitoring. The rise of wireless technological advancements generally opens new horizon of possibilities for manufacturers, and with traditional wired systems, the condition monitoring assets can be quite costly. It can be also staff-intensive process, and generally collecting and sending data to the main server, which is stored at the plant, can be quite an inconvenience. And also, at these cases, an individual engineer would have to visit the plant and inspect the data on a specific given computer. And such approach leads us to the point where determining issues and making certain recommendations could take many hours, if not days. And it's believed that with the recent global disruption, this issue became more relevant than ever before. In essence, wireless technologies eliminate any need for hardwiring and other sensor cables, which allows this kind of system to be more robust, more scalable, and generally more convenient for the use. But at the same time, it's fair to state that the wireless approach is not necessarily fit for all solution, and both of these systems have their own pros and cons. And where one solution might be the right answer for the needs of one section of the facility, the other could be the right for somewhere else. And as you might see on the slide, there are some of the challenges of wired system is related to difficulties with scalability and mobility, as well as general time consumption for the installation process, as well as there is some other risk related with physical cable damages that could occur in the plant environments, and also the implications behind wired systems is about critical assets, which leads to a point where mid-critical and low-critical assets from which a lot of value could be generated is left aside. Last but not least, these kind of systems are quite expensive, and they obviously require consideration before any investment occurs. On the other hand, wireless system has also posed certain challenges to manufacturers, and this is related to the reliability of the devices, since those are battery-powered devices, and some of the reliability matters could be quite questionable. As well, there are implications behind battery life, and that can cause both time-consuming efforts as well as monetary investments for changing the battery. And there are some other network related issues, since there are many different radio frequencies that are situated within the plant. And also, both wired and wireless system at the moment have quite rigid and complex configurability. So that leads us to a point where it's quite hard to conduct any configurability after the devices have been deployed. And last but not least, despite the fact that wireless systems are considered as more affordable than wired systems, they are still more or less expensive, and they also require consideration before any investment occurs. The bottom line here is that wireless systems are still not a perfect solution, and there are still some existing technological challenges that persist. However, Treon, together with Sulzer, have developed a solution that effectively solves these challenges. And with this sentence, I will give the word to Janne, who will introduce Treon's solution and elaborate why it brings the benefits of wireless condition monitoring on a completely new level and scale.
Hello everyone, good day. Thank you very much for joining our webinar. My name is Janne Julkonen, I'm the Chief Product Officer at Treon. Just a second, I'm getting my slides ready for sharing. Thanks, Ibek. That was, I hope you are seeing now what I'm sharing. Excellent. And thank you, Ibek, for very good introduction into the predictive maintenance and wireless condition monitoring, which is a key enabler for predictive maintenance. So this is our product, Treon Industrial Node, that is intended for wireless condition monitoring. It's a wireless vibration and temperature sensor. It's battery operated, and it's a highly robust device that is designed for difficult industrial environments. The quality of the data is very important for condition monitoring and for the predictive maintenance, since all the analysis relies on the validity of the data. So it's a super critical part. And now that all goes into actual capabilities of the sensor component, and it goes into the mechanical design of the actual sensor device, and it goes into how the device is mounted on the rotating equipment it's monitoring. Now in Treon Industrial Node, we are using an industrial grade pre-calibrated sensor and a mechanical design that provides data within the standard-based error margins up to 1 kHz of frequency range. Now the mounting of the Treon Industrial Node can be done with an integrated bolt that is generally considered the most I've just flagged by Ibek that my slide is not fully visible. Sorry, Ibek, I have no really. Let's try this again. Sorry about that. Any better, Ibek? No, it's the same. Okay, let me try sharing my whole screen. Excellent. All right, sorry about the interruption, but hopefully now everybody can see my full slide. So anyway, I was talking about the integration or the mounting of the node into the rotating equipment that it's monitoring. So in Treon Industrial Node, it can be done with the integrated bolt, which generally is considered the most accurate method, or the method to mount with which produce the least potential errors into the measurement data. So, and the temperature sensor that is integrated in the device is actually integrated within the bolt of the sensor device, which gives us extremely accurate surface temperature measurements. So we are reacting very quickly to the temperature changes, since the temperature sensor is actually within the surface of the machine. And also we are getting very accurate measurements for the surface temperature, just within a few Celsius degrees. Now the device is capable of sending both raw acceleration data. So if there is a backend or analysis software that wants to use raw data for and analyze that itself, that is possible. And also the device is capable of sending what we call calculated data. So we can send RMS values for each axis, kurtosis or FFT with the 1 Hz speed. So it's perfectly configurable and a choice of the backend or the customer what kind of data they want to receive. And the Treon gateway is another key part of the whole system, which I'll talk more about in the next slide. The whole measurement data from the sensor devices is transferred to the backend, whether that's in-premise or cloud, via wireless mesh network. The radio in the devices is same as in Bluetooth, so it's a 2.4 gigahertz short-range radio. But instead of Bluetooth software, we are using something we feel is more suitable for industrial applications, and it's called WIREPAS mesh. So we are basically replacing the Bluetooth software stack from the devices with the WIREPAS mesh software stack. The WIREPAS mesh is a highly scalable and robust connectivity method that is very resilient to the network interference, which is a key feature in difficult industrial environments. So the measurement data is routed to the gateway from the measurement devices, which are called nodes. And if needed, the data is routed via other devices. So not all devices need to be directly connected to the gateway to send their data, but they can also send data via each other. So every node can be both a measurement device as well as a routing device. It is also possible to dedicate nodes to only routing data if you want to bridge gaps in distances by adding additional devices in between. The whole network management is completely automatic, so there is no centralized network management for the network. So the nodes are all the time automatically and individually making connectivity decisions with the goal of optimizing the connectivity to the gateway and finding the best route to send the data to the gateway while minimizing battery consumption. The WIREPAS mesh is, as said, highly resilient to bad network conditions and interference, and the nodes are constantly optimizing their transmit power and, for example, which network channel they are using to make sure that the data gets to the gateway in the best possible way. The system is perfectly scalable. So here you can see maybe a dozen or 15 nodes connected to the gateway, but it could as easily be tens of nodes, or it could be hundreds of nodes. New nodes can be added or removed to the system completely without any management. So when you power on a new node and you add it to the system, it's automatically connected and starts routing and sending its data to the gateway. It's also possible to add other sensor devices. It doesn't only have to be the Treon industrial node to the system. You could have a, let's say, pressure sensor or temperature or humidity sensors in your plant, measuring data and sending it to the gateway via gateway to the backend in the same WIREPAS mesh network. And it doesn't have to be even Treon sensor devices. It could be third-party WIREPAS sensors that are connected to the same network, sending their data via the other devices to the gateway. Now, once the data reaches the gateway, it can be processed there. It can be sent to the backend over a secure connection. And the backend, as said, can be both in the cloud or it can be in-premise. The connectivity methods that the gateway offers are wired Ethernet connection, Wi-Fi connection, and a cellular connection. So it's, again, completely up to the customer which connectivity they want to use. And this line here on the right side is where Treon stops. So we do not force our customers to any vertical service offered by us. And openness and providing choice for customers has always been very important for us. So we have specified certain interfaces and data formats that are used to send data to the backend, the measurement data, and also different data formats for sending configuration commands or device management commands from the backend to the gateway all the way to the nodes. And this is a very critical part of the system, as we believe the configurability, whether it's how the nodes are measuring vibration and what data they are sending, or the ability to update software in the gateway and the nodes later, it's super important for the whole system. So any customer can implement their own backend or integrate to existing backend using our interface, whether that's in cloud or in premise, to analyze, visualize, and store the data. And if you don't want to build your own backend, we have partners who can offer you the backend and have already implemented a backend against our interfaces using our devices. And we have two such companies here in the call with us today, with both Sulzer and then Danfoss, who are great examples of such companies. Now, as wireless technology is making its headway to condition monitoring, there starts to be an increasing number of choices available for customers. And why Treon Industrial Node and the Treon platform for enabling wireless condition monitoring? So we like to think that one of the key reasons is the openness and our horizontal approach, which I described. So we don't force customers to any specific vertical service, or we don't have any intermediate servers or backends to route data to the customer cloud or backend, but we completely leave that to our customers, and they can own the data and they can manage the whole backends by themselves. But there are a bunch of other reasons as well, and here are some of these reasons. And the first one is the remote configurability. So once the device has been deployed in a plant to a rotating equipment, it doesn't stay the same. So not all condition monitoring needs are the same. So machines are different and processes in factories vary. So in some cases, our customer may wish to measure vibration and temperature every 15 minutes. Sometimes they may wish to measure it once a day only. In other cases, our customers may wish to keep track of just the temperature, while in other cases they want to have raw vibration data for their own analysis software. And sometimes these needs may change during the deployment. So customer may have started by tracking RMS regularly, let's say every once an hour, and then they notice a worrying trend based on the RMS, which is this total energy of the vibration, and they want to receive FFT or raw data to analyze this phenomena more closely. So all this is possible by sending remote commands or simple device management commands from the backend via the gateway to the nodes. So you can fully configure how the vibration is measured. For example, you can change how many samples are taken per second, we could call it sampling rate, or you can change the length of the measurement sample. So what data you want to receive, whether it's RMS or temperature, FFT or raw vibration data, all that is 100% configurable. And you can also control when you want to receive it. So you can receive it on a time-based interval, which can be flexibly changed, or it can be based on the on-demand request, or it can be triggered by exceeding a vibration threshold. So you are not measuring vibration unless there actually is vibration. Second is the optimizing the data, which is very much built on our ability to configure the nodes. So if you are all the time sending raw vibration data and as efficient as WIREPAS mesh is for transferring the data, sending raw data frequently in large networks is not that practical, and in most cases it also doesn't make sense. So if all the analyst wants to do is to track RMS trends. And this is the reason why we do key calculations all the way in the very edge of the network, if you like, in the Treon Industrial Node. And if a customer so wishes, node can send raw measurement data, but we can also calculate RMS, kurtosis peak, peak to peak, and FFT in the node. And we even compress the FFT before we send it. And now we have calculated that comparing to sending raw data all the time, we are reduce the data amounts by 74% if we are calculate the FFT in the node and send it to the backend. And we can reduce it by up to 99% if we just send RMS, which is calculated in the node, compared to sending raw data. So this gives lots of opportunities to optimize how the system works and avoid unnecessary data sending over short-range wireless radio, which makes the whole system work much better and more optimized. And this also enables much more efficient uses of battery as well. So if we are not sending lots of data and if we are not sending too often, we can extend the battery life in optimal temperature conditions even up to 7 years. So this is calculated sending RMS once per hour in optimal temperature, and the device can run up to 7 years. And now even if we send data every 15 minutes and more data, including FFT, we are still getting multiple years of battery life. So this flexibility and configurability and calculating data in the node gives us much opportunities to extend the battery life and not shorten it unnecessarily. And then compared to the wired system, so it's pretty clear that, and as Ibek already talked about, it's pretty clear that faster and more cost-efficient deployment is one of the key drivers for wireless systems. So you don't need the data cabling, you don't need the power cabling. All you need to do is to plug the device into a rotating equipment and turn it on. And in some environments, it may not even be possible to go and do wiring in kind of hard to reach locations. And we have data and calculations that in some cases, the deploying a wireless system can be up to 15 times faster than do a wired-based system. And now if you have a factory with hundreds or even some thousands of rotating equipment you want to monitor, this is a huge benefit, which leads then to the significant cost savings. Again, we have data and calculations that deploying a wireless system, also calculating the lower cost of the wireless device into the play, it can be up to 4 times less expensive than deploying a wired system. So hopefully this convinces you that if you want to go wireless for condition monitoring, Treon industrial node and the Treon gateway and our platform is the right choice to pilot and try. And now I will give the stage to Matthew from Sulzer, who we have worked successfully for a long time in building this system. And it's been a great experience, and I trust that Matthew has a lot of interesting things to tell us about how our system works in practice.
I'm sure I have, thank you. Okay, so does everyone see my screen first of all?
Not yet, Matthew.
Okay. 1 second, bear with me, everybody. Okay, do you have that?
Yeah, we can see your full screen, including the speaker notes.
Yes, okay, that's not good. Do you have that now? Sorry, Janne.
Yeah, now it's good.
Okay, thank you very much. Okay. Good morning, everybody. My name is Matthew Anderson. I'm the Data Analytics and Smart Technologies Manager at Sulzer. And as part of my remit, we've been co-developing a product with Treon, which we call the Sulzer Sense. As part of the success story, I'm going to walk you through a little bit about condition monitoring, about the problem that we addressed with the Sulzer Sense, a bit about how we came to work with Treon. But first, I need to tell you a little bit about Sulzer so this all sort of sets the scene. Okay. So first of all, a bit about Sulzer. So Sulzer are one of the world's leading fluid engineering companies with over 15,000 employees worldwide and a global reach of over 100 countries. Not that I'm going to be able to name 100 countries. Sulzer has 4 key divisions. And as part of this, I'm going to highlight 2 of these for today's discussion. The first one is our pumps equipments. Within this division, we design and manufacture pumps for a wide range of market segments and applications. So these are segments such as water and wastewater, power generation, oil and gas, which includes the upstream, downstream, midstream segments, and also industry, which covers a lot of subsegments such as pulp and paper, food production, mine dewatering. Now, within this entire division and across these segments, we encompass the full manufacturing spectrum from highly engineered, configured to order, towards a more of a larger produced volume product, and all the steps in between. So it's a wide range of engineering and manufacturing skill sets there. We don't just manufacture. So the other division I will mention is our rotating equipment services. From this division, we service all types of rotating equipments. So this is things such as pumps, blowers, compressors, motors, turbines, agitators, all rotating industrial equipments, and also not just our own products too, but also third-party ones also are an important part of the service we provide. As part of that service, we cover things such as spares, repairs, retrofits, all the service needs for our industrial customers. Now, I really want to include this slide. Really this shows the history. This Industry 4.0 idea that Janne mentioned of using these cost-effective IoT sensors for condition monitoring. It's not our first industrial revolution. Sulzer has a history of engineering innovation that stretches back nearly 2 centuries, you can see here. And this industrial experience, this innovative mindset, and this application of these disruptive technologies to traditional industries is really what sets us apart from the competition. And it's really what we bring to the table in the partnerships such as the one with Treon. Now I'm going to talk a little bit about the problem that we're addressing, which is condition monitoring, for which we designed the Sulzer Sense. So if we imagine the target here is really the industrial segment. So if you can imagine factories, paper mills, food production lines, perhaps clusters of pumps and motors in close proximity together. The factory owner will need insights into the reliability of their industrial equipment. Now, they tend not to have a large investment in sensors, in collection systems, or process historians. They tend to rely on manual inspection. So this is literally an engineer will walk around with a handheld meter. They'll take measurements of vibration and temperature and manually and note those down. And obviously this has limitations. First of all, the obvious one is fairly infrequent. There's a lot of effort involved in actually going around and physically inspecting each of these things. So it tends to happen maybe once a month, maybe less frequently. The second limitation is that you can only measure things when they're running. And quite often in some of these environments, you might not run these assets 24/7. And lastly, the third thing I'd highlight is that you can only measure things that you can reach if something's working at height, for instance, and you might need a special certification to work at there, or you can only measure things that are safe to approach. So that limits you quite a way, and that you end up with only, at best, you end up with snapshots of the asset behavior. Worst case, these are getting written down on a piece of paper on a clipboard, and there's no continuity from one measurement to another. And this really limits you. You miss an opportunity to see the underlying patterns and problems that might be occurring within your environment. And that's really why we started looking at condition monitoring solutions such as the Sulzer Sense. So really, this is where the Sulzer Sense comes into play. As mentioned, we co-developed this product with Treon. The aim was to produce a cost-efficient sensor to aid us with these reliability measurements in these types of environments. What was quite important was that the device was simple to install. We don't have teams of people who can install this for our customers. We need the customers to be self-sufficient and install it in a very simple manner, but also simple to use and simple to maintain. So the aim here will be for the customer to fit this to bearing housing of any rotating equipment via a standard size thread, which you can see this bolt here at the bottom would screw into. This could be one of our pumps or perhaps a third-party product. Now, as mentioned by Janne, the sensor measures triaxial vibration and temperature of an equipment. Temperature and vibration two good indicators of an equipment's reliability. Basically how hot it's getting, how much it's moving around, tell you how well your asset's performing, and gives you some insight into the reliability and the longevity of the asset. This sensor learning data is captured via a gateway via this mesh connectivity, and from the gateway it's transferred to a cloud environment for deeper analysis. I'm going to jump onto the next slide. I want to go back to this mesh architecture that Janne mentioned. One of the key differentiators really is the telecoms in this product. Quite often when you look at competing products, you'll see things such as Bluetooth stacks, which isn't the most secure approach. You'll see things such as Wi-Fi, which again is a limitation because it's very volatile depending on the environment. If you can imagine where these things are being used, we're talking factory floors. They're always optimizing the factory floor layouts. They're doing their lean improvements and adjusting the production flow. So essentially, you've got these little Faraday cages moving around your shop floor, and your carefully planned Wi-Fi will suddenly stop working because you'll have some sort of interference that you didn't have before. So we needed something that was more resilient, which is this mesh connectivity that you see here. So aside from being scalable for all the different assets we have there, it's also a very resilient approach. So as mentioned, these sensors can act as a router or a measurement sensor. The data goes back to a gateway, which connects out via a variety of mechanisms. It could be an Ethernet cable, onboard modem, a USB modem that's connected in here, or connection to a wireless network. And that data is transferred to our cloud environment. So here you can see data after it's been transferred to the cloud environment, we get a visualization. The visualization can be viewed from any connected device, such as a smartphone, a tablet, or a PC. There you would have a threshold for acceptable vibration and temperature, and you can receive alerts and reports, which you can see here. So in these ones, we've got an alert for vibration for this asset. Temperature's doing fine. But maybe I want to look at that one, so I'll drill down into that asset, investigate the underlying trends from this front end, and perform some root cause analysis into the asset's behavior. So here we can see the temperature, we can see it's fine, there's a threshold, it's below the threshold. But here the vibration in the 3 different axes is above the threshold. As mentioned, we can see these things by time, which is quite a useful thing for the customer. But we can also see them by other dimensions also. So here we take a fast Fourier transform, which is essentially we see it in a frequency range rather than a temperature range. And that kind of acts as a fingerprint for the rotating equipment's vibration behavior. Now, all of this is accessible to the customer. It's simply presented, easy to follow, and helps them plan their actions based on this information. And that's really a very quick overview of the Sulzer Sense. But I'll be happy to take any questions at the end of the presentation. A little bit about how we came to partner with Treon before I close. So why do we partner with Treon? To find a more efficient solution to condition monitoring. So we were looking at ways to address this problem. And whilst we had a lot of the skill sets internally, we never really tackled it at this level, at this price point, or targeting these lower criticality assets. And we realized quite quickly that we needed some help on the subject. So my very knowledgeable colleague, Sami Saranvalta, attended a number of technology forums where he raised this as a challenge. And this led us to partnering with 2 Finnish technology leaders in IoT innovation who really stood out from other companies we talked to. First, we partnered with Treon for their expertise in sensors, accelerometers, communications, and so on. And secondly, a company called Pilot, who brought in experience on the back-end side, the Azure IoT data platform, which we use for our standardized data collection for all our digital products rather. For the presentation, and linking it also to our internal ERP systems. And for us, it's been a perfect match of skills and experience, really. Some of the smartest, most innovative people I've had the pleasure to work with. So I think Sulzer and Treon together really makes sense. And with that, I shall swipe right and hand over the presentation. Thank you very much, everybody.
Thank you very much, Matthew, for such a descriptive elaboration on Sulzer Sense and partnership with Treon. And yes, if you guys have any questions to Matthew or Janne, you can ask those questions already now, and we will make sure that we come back to them by the end of this webinar. And on this note, I will give the presenter rights to Simo and mute myself.
All right, thank you. I will start screening now. I hope that it is showing well. Please confirm that.
Perfectly well.
All right, very good. So really, my name is Simo Kekkonen. I'm leading the IoT technology in Danfoss Drives. Of course, the name says, or title says IoT, but actually it is more about industrial internet, because we are not working really in the B2C area, but we are only working in the B2B area. Also, I have some information about what Danfoss Drives is in a very short, compact way. Then some questions about that, how we are helping our customers, how we are using actually the Treon sensors, and then something about how the architecture and the system really works from the, let's say, from engineer view. About Danfoss Drives, maybe those Finns who are here know also brand Vacon, because Danfoss actually bought Vacon 5 years ago, and now we are part of the Danfoss Drives, and the brands are BLT and Vacon that we mostly make. And our annual revenue is about 1,500 million. We have delivered almost 30 million drives, so we can say that the install base that we can reach with this solution that I am presenting is something between 10 to 29 million or 27 million devices install base, which is huge. We also deliver in one of our branches equipment to electric vehicles. So that is one growing area, but that is also part of Danfoss Drives business. We have about 1,000 partner companies. We have activities in 100 countries, sales offices in 50 countries, and we have 10 factories globally. And this is really the first mover. Danfoss actually invented the first frequency converter already in 1968. So it has been in the business 50 years, which also explains the huge number of install base. And regarding the digitalization, we have it in our focus area. It is very important for us. We are investing on it. We are developing products and especially services to be even easier to work with. So that way we are engineering tomorrow, which is our slogan. How wireless is helping our customers? It is obvious that many of the benefits have already been mentioned, but I will express my view on it. So one of the most important probably for our customers is the cost of the installation and drastically less cabling, because the cabling is then not an issue. So all the materials needed for the cabling, space needed for the cabling, installation and commissioning time related into that. That is one, I think, the biggest driver that our customers most probably feel. Then, of course, the mesh network that has been well introduced in the previous presentations, it is a big benefit, the reliability of it, and especially when you have more than one sensor, then all the benefits come more clear. In the industrial environment, this is, of course, very important that we have robust communication. Then it has been also mentioned earlier that the sensor itself can provide more than just raw data. This is also important for our customers. In Jana's presentation, this was very well elaborated, so I will not drill into this more. How then we are using Treon? The wireless is a very obvious benefit of Treon sensors, and Danfoss Drives has now possibility to easily create real information about the actual process. I'm not saying the process that the Danfoss Drives AC Drives see, but the real process which actually is working. And we can offer the visibility to both the motor behavior and the usual suspects like vibration and temperature, which has been also presented in the previous presentation clearly. The use cases simply are, these are just as examples. There are a huge number of examples, but for example, a simple like in heating, ventilation, air conditioning, the resonance area is very important. Normally, in the AC drive, we set up a preset value for the frequency that we should try to avoid, meaning that we are skipping it very rapidly over so that we don't create resonance to the air conditioning devices. Now we can also use that so that we can measure the real resonance area, which is a clear benefit. For example, during the commissioning, why not even with the fixed device in the system? And the wearing and tearing problems visualization. For example, the elevator car position. When the elevator car position, I mean the vertical position, when the car is going up and down, then it can be that during the years, the temperature variations, whatever, will, for example, bend the rails. Then it can be that some part of the rails there is vibration, or even that we can see that the torque of the motor or the current of the motor is higher in that place. It can be a sign that actually in that area the rails are already bent or damaged, so it can lead to the discontinuity of the service, meaning that the car can stop into that. Of course, in Finland we don't have such big temperature variations easily, maybe today, but usually not. But in many other hot countries, it can be really a problem that the rails of the elevator are somehow bent during due to temperature changes. And then we also use or can use the Treon sensors for R&D, because they are very handy. You can move the sensor in troubleshooting case and try to find that where actually the vibration is felt mostly, or temperature, for example. So it's obvious that the long battery life and the easy movability is ideal for troubleshooting purposes. Of course, like in any industrial equipment, there are situations when there is some trouble in the process, and it is way easier to find it if we can study the temperature and vibration with a very simple and reliable tool. Then something about that how actually our remote monitoring works. We don't have such a product as IoT. We have a service product which is called DrivePro Remote Monitoring. I will put the laser on. So we are using this service product, and then we can apply actually Treon Gateway on parallel to it, so that we can that way add much more information. I'm not saying that we will add more data. We are actually creating real information, which I try to elaborate with this presentation. So like mentioned, we have 10 to 27 million installed base globally, which is a huge asset actually for us, because then we can access to all the data that we have. For example, this device, the VLD drive, we have 1900 parameters in there, and we can access all of those. Also, this device, by the way, has a possibility for edge computing for condition-based monitoring. So the drive itself can make condition-based monitoring, or we can then use this system to visualize that. All of these can be mixed, so that we can mix the different product families. We can use different kind of bus connections to our gateway. Our gateway is communicating to Danfoss Cloud, which at the moment is Microsoft Azure, but it is not only Microsoft Azure. We also have their product from the market. We are using a product from WIREPAS IoT ticket platform, which we decided to be cloud agnostic. Means that if we want, we can change the cloud. We are not having the very strong vendor locking to Microsoft Azure, but we can use as well AWS or Google or Alibaba, whatever. So this is a great benefit and a strategic decision from us. Then I think that I hope that I have, yes, there is the next part is of course the user interface, so that how can we monitor the things that we are seeing through this system. We can access by desktop or mobile phone or pad, and we have the visibility of these dashboards. These dashboards are totally configurable, or not configurable, they are tailorable, so that you can, only imagination is more or less limiting that what you can show in here. Then of course, what are we doing with the drives? The AC drive is usually controlling the speed and or torque of the AC motor, and this is just doesn't look very much with like any motor on the market, because obviously we don't need to market our competitors, but then we have these Treon sensors, and simply the Treon sensor, actually that small point there is indicating the Treon sensor on a very huge motor that we have in our facility in Vaasa. And then we have the Treon gateway, which is also connected to our IoT ticket tool. It means literally that we can get the information of the vibration or temperature of this sensor, and we can combine that in time to the real RPM of the motor. Of course, it can be anything else than RPM. It can be current or torque or whatever of those hundreds of parameters that we can take from here. Here you can, by the way, see these arrows, which are more or less reflecting the heartbeat that we are taking from our motor. So this will continue 24/7 from now to eternity. And then we have the possibility to take the data out from our cloud to customer cloud by utilizing the REST interface, which is the mostly used interface between cloud-to-cloud connections. So this is how we are utilizing the Treon sensors, and this is real-life installation from Vaasa. We have also installation with our customers. So I can say that immediately when I saw first time this sensor, and I actually got it on my hand, I knew that, okay, this is something that we really can use in our business to help our customers in especially preventing the unwanted production problems. That's more or less it that I had. Thank you for your attention, and I will give back to Aive.
Thank you very much, Simo, for such insightful and informative presentation. Now we have our Q&A session. I will quickly get the presenters right to myself. At the moment, we do not have many questions that have been posed by our attendees. We will take that as a compliment that we have done a great job at describing Treon Industrial Node and Treon Gateway. But there is one question, if I'm not mistaken, for Janne. The question is, which pump failure cause can you track with your product? I'll give the word to Janne. This one.
Hey, thank you, Aive. It's a very good question. So first, for the Treon philosophy, so as I explained earlier, so what we do is we send and provide data, the best possible data in the most efficient way to the backend. And then in the backend is the actual analytics of the data. So we don't analyze the data, even though we do calculate it from the raw data in some cases to RMS, etc. Now, the limiting factor in detecting faults is most likely the frequency range that node supports. So we go up to 1 kilohertz, so which is perfectly sufficient for detecting most possible faults with the pumps such as imbalance or misalignment, cavitation, resonance, etc. Now, and I think it's also enough to detect bearing issues, maybe not necessarily in a very early stage, but certainly before they become kind of clear faults. What there will most likely be issues with is, for example, lubrication-related faults. So those will require such a high frequency ranges that 1 kilohertz is just not enough. So to detect those, you will need to wait for our future products, which will provide a wider frequency range for measuring. Now, hopefully that answers your question.
Thank you very much, Janne. Yes, and I think it's very important to mention that if you might have any questions, then I will provide with an information of the emails of today's speakers, and if you might have any specific questions, you're always welcome to ask these questions. And to sum up the whole webinar, we hope that this is something that you have enjoyed and you have gathered and insightful for yourself information. Please do contact us. We'll be really happy to proceed with more detailed conversation on our product and yes, make great things together. Thank you very much for all of our attendees that have attended this webinar, and also for our speakers. One more important thing that we would like to that we would like to mention about is related to our webinar platform that we are going to arrange on 7th of July around the same time, between 10 and 11. And in this webinar, we'll talk about our unique IoT platform, which is an open, scalable, and cost-efficient solution for IoT development. This webinar will be held with global leader in automation, Schaeffler, as well as Pilot. And we'll be really looking forward to have you also in that webinar. Thank you very much, and bye-bye.